All right, here we go, Calc disciples. Rocking and rolling to the next part of what we're going to get into. It is the fundamental theorem of calculus. So it looks pretty intense and crazy, but I'm just going to let you know that it's what we've been doing. All right, so we've been evaluating integrals. And right now, it's been an indefinite integral, no boundary. So the fundamental theorem of calculus is when we have a definite integral, all right, or a boundary, and we're going to actually evaluate. We're going to have numbers within our integral interval that are going to allow us to actually find out what the area is under the curve, right? So remember, from day one, you needed to remember integral is the area under a curve. Area under a curve. And we've just been getting the equation with our boy Carlos. Now we have the ability to figure out what the area is going to be, and we don't need Carlos anymore. So, a couple things that we're going to do, all right? These big F's, all right, that is the function when we integrate it, all right? So what we're going to do is we're going to integrate the function just like we normally would. Then what we're going to do is we're going to plug in our boundaries, starting with the rightmost boundary first on the top. The rightmost boundaries on the top, the leftmost boundaries on the bottom. So smaller number, bigger number. Okay? Now, we're going to evaluate the integral, and then what we're going to do is we're going to plug in the rightmost boundary, we're going to plug in the leftmost boundary, and then we're going to subtract their values. And then that answer is what our integral value is going to be. Okay? Again, this is a definite integral. So here we go. Let's look at an example. We now have boundaries, right? We're going to integrate this the same way like we normally would. So we'd start with this x squared. We'd integrate it. Right? We know x squared becomes x cubed over 3. Plus the 2x. We're focusing on the x just like we did before. The x becomes x squared over 2. The 2 in the front just gets brought down. They're going to reduce. So when we integrate this and reduce it, this is what it becomes. Now some of you, especially John, are probably saying, what is this, Coach Dale? What is this bar? Right? Remember, John, this is the bar that means evaluate. So I'm not going to be picky if you guys don't write this. All right, it's all good. But again, just showing you that this means evaluate. So that's our integral. We integrated just like we've been doing. We're going to evaluate it from 1 to 3. We're going to take 3. We're going to plug it in for those x's. Right, so this is what we integrated. We're taking 3 and replacing it. Minus, right, f of b minus f of a. Now we're taking the 1 and plugging it in for the x's. And then we're just going to simplify it out. So here, in the beginning, this first part simplifies to 9. 3 squared is obviously 9. And the next part, this becomes a 1/3 plus 1. We're all pretty good in here, but 9 plus 9 is 18. 1/3 plus 1, right? 1 and 1/3, 4/3, however you want to express it. And now we can fully simplify. 18 minus 1 and 1/3. 16 and 2/3. So this is the area under the curve. All right? So again, just what we've been doing. Now we're plugging some numbers in. Now here's the last part of this. All right? Because obviously It could be any of our integral methods that we did. It could be if it's underneath a radical. It could be if we need to use substitution, right? It can be our favorite, the trig functions. So don't get confused, right? I know it's a you try. So with the sake of technology, you'd all be able to hit the pause button. But I'm going to keep rocking and rolling here. So integral of sine. Sine integrates to negative cosine. And now we're going to plug in 0.5. Remember, it's the top minus the bottom when we plug it in. So first we're going to plug in the pi over 2 minus and then cosine of 0, right? Now, gotta make sure you're good with your functions, making sure you got the calculator correct. So here it's given in terms of pi, so we gotta have that calculator in radians, right? If it was given, and you'll see it most commonly, these will be given to you in radians. You will not get degrees too often, all right? But also being good with your trig functions, right? Remembering what the cosine function looks like. If you remember, cosine of pi over 2, right, where it falls on the graph, that's just going to be a 0 for us. The negative here is in front, so keeping that in mind, right, careful with our signs. We don't have to make it a negative 0 though, right, no such thing. Minus cosine of 0 is 1. But with the negative in front, makes it a negative 1. So then when we fully simplify, 0 minus a negative 1 really turns into adding positive 1. So the area under the curve on this boundary is 1. All right? Like always, let me know if we got any questions. If you're stuck, confused, reach out to me. All right? And then, again, don't forget, we're going to be meeting later in the week on Thursday. All right?